Hi guys, so my project was on predicting taxi fares in New York City. So, as you guys all know, cities are very highly populated and they're dense. And a lot of people in cities don't actually own cars, and as a result, they don't drive cars to get around. So the way that people usually get around is through taxis or ride sharing. That's the preferred way to move about the city. And so for businesses like taxi companies, Uber and Lyft, this presents a problem. How can they accurately predict the price of rides that people are taking? And you guys might think, hey, wait a minute. Uber and Lyft already tell me how much any ride costs whenever I put my location into the app. And the thing you have to remember is that actually wasn't always like this. And the question you should be asking yourself is, how do they do this? How do they tell me how much the price of the ride is? And the answer to this question is, of course, machine learning. So why do they actually care about doing this pricing? And as I said before, they didn't always have exact price prediction. They used to give you price ranges. So we can see here on the left, the Uber would give you a price range for a location. And this is actually a very bad user experience. So this is vulnerable to things like if you're in a snowstorm or if there's some weird circumstances happening, you can end up getting prices that are much outside of this price prediction range they gave you. So a few years back, you could get a fare for hundreds of dollars if there was a snowstorm. Additionally, this provides increased friction for users who want to actually use the service. You can intuitively understand that if I don't know exactly how much I'm going to pay for something up front, I'm going to be less willing to book a ride with Uber or Lyft. And finally, these companies want to have as low a fare estimate as possible. Ride sharing is a very price elastic market, and users are very price sensitive to how much they're paying. So they get a competitive advantage if they can predict and provide you a very low fare. So all of these things are going to help their bottom line if we can make very accurate predictions. So the actual data set is from Kaggle. It's a New York City taxicab data set. It has 55 million rows. And here are some of the rows, for example. So we can see we have timestamp, we have location data from pickup and drop off, we have passenger numbers, and we have the fare amount. And so I did some data cleaning and feature selection on this, and I've made this graph. So this is just Manhattan distance from any one selection. And we can see there's a correlation between the Manhattan distance starting and ending location and the fare of the ride. And the astute observer would say, hey, this has a linear correlation. Let's run linear regression on this. And it's actually a pretty good idea. So linear regression will have about a $5 error. And the problem is that $5 actually is not very good for this problem. As we saw on this previous row, a lot of these fares are less than $5 or around $5. And in the 55 million rows, the mean fare is about $10 to $11. So if we have an error of plus or minus $5, that's actually really, really bad, and it's going to hurt our business. So the question is, how can we do better than that $5 of error? And the answer to this is deep learning. So why is deep learning good in this situation? So for one, we have a very large data set. And the reason why deep learning has improved in performance in recent years is that we've had larger and larger data sets to apply these algorithms to. And large neural networks are simply very effective when we have a large data set to deal with and to train the model on. Additionally, there's some nonlinearities in this data. You can imagine that if we do more advanced feature selection, like where the actual location that we're starting and ending is. There could be different spots in New York that are more expensive to go to or more expensive to come from. For example, let's say the airport. It's clearly going to be an expensive ride. And there's other things like the time of the year, the time of the day. These all are nonlinear features that we want to be able to catch. And if we can catch those and make some correlation, we can make more accurate predictions. And so the theory is that, hey, if we use more advanced feature engineering and we use a deep neural network, we're going to be able to make very good predictions. And hopefully we can get our error about less than $1, and that's going to help our business a lot. Thank you.